This video is provided by Coaching Online iit-jee and delivered by Praveen Kumar Pandey. This is free tutorial videos which helps iit-jee and medical entrance exam aspirant in secure a rank. In all the lecture series we will solve previous year's question of iit-jee and medical entrance exam. We will solve physics, chemistry and mathematics question and explain all the fact related to problems in great depth, and an cutting-edge analysis is provided. Our team upload one video per day. So to get daily update, subscribe our channel. Special thank you to my dad Shri Amrendra Kumar Pandey, G, and my mom Shri Neelam Pandey, G. I dedicate this videos to my younger sister Miss Pratima Pandey. Thank you for tolerating me during making the videos. Without you this is not possible. Thank you.
Welcome to free online coaching. This is Praveen Kumar Pandey, your online tutor. And now in today's class we are going to see some more example on Newton's law. Okay, so in yesterday class in last step we had learned about wedge, a particle. What happened to a particle when it is kept on a wedge. Okay, so this angle is theta, okay. So this wedge is fixed. This wedge is fixed. It is given in the question. Let me recall it. This wedge is fixed. Okay, fixed. Okay, fixed. And let me okay, and it is in gravity. Suppose this mass is m. It is in gravity. So what will be mass of this? Mass of this is, due to gravity there will be a force. Okay, there will be a force which is just vertically, and this force will be mg. Okay, always vertical. Force due to gravity is always vertical. This is horizontal, this is vertical. Okay, and this angle will be theta, no doubt. This angle will be theta. Okay, now this block is not moving in this manner. Okay, its motion is not. This is not the path of motion. This is not, and in correct mathematical way we should say this is the not locus of this particle. Okay, this is not path, not path of motion. Okay, this particle will not move, do not move in this manner. Okay, this particle will not move in this manner. What is the path? What is the path of motion? This is the locus of motion. Okay, this is this direction. Particle will move in this manner. Okay, it is not start flying in air and falling down in this manner. Okay, this is not the path of motion. So for it, what is the required? There since initial this particle is in rest. If path is in this manner, then there should be acceleration in vertical direction, but this is the not path. Okay, this is the not path. So acceleration in vertical direction, sorry, I should not say vertical direction. Acceleration in along the normal to the plane, along normal to the this base, this surface of base. Acceleration along the normal to the surface of base is 0. Okay, so this angle is theta. This angle will be 90 degree. This angle will be 90 minus theta. This angle will be theta. This is the mg. So what is the component along this? This is the mg cos theta. Okay, this is the mg cos theta. And here is the surface. There is a contact between block and wedge surface. So the wedge surface will apply a force which is perpendicular to its surface. Okay, this is the n. This is the n. Okay, so since there is no acceleration along this direction, along vertical normal, along the normal to the base this surface. So what can I write? N minus mg cos theta should equal to 0. Why it should be equal to 0? Because acceleration is 0, and by Newton's second law, m into a is 0. So this is become 0. So what is the n? N is equal to mg sin theta, mg cos theta. Okay, and you know. And what is the component? Since motion is along this direction, you know guys, we should since motion is along this direction, we should take this direction as a positive and perpendicular to it along negative. Okay, this is the this is the direction of motion. Okay, so I had take this as this as my main axis. Okay, and take a component of vertical axis mg along this and this. Okay, so what should be the principal axis? You should choose and depend upon motion. You know, in most of the case, when you choose the principal axis along the motion, then your question become easy. Okay, so n is equal to mg cos theta, or what is the and what is the force? What is the force along this? Which is mg sin theta. Force along this inclined plane. Force along this inclined plane. Okay, inclined plane. Force along inclined plane will be mg sin theta, and this is equal to m into a by Newton's second law. So a is equal to g sin theta, and this we had studied in yesterday class. Okay guys, so now I am going to give some more example. Okay, some more example, different type of example on it, and all the example are very simple, and these are the very simple question. You know, it is just for practice and to boost your concept. And if you wanted to see which type of question we can solve in Newton's law, then you should start seeing lecture 1, 2, 3. Okay, and whatever. Okay, so let me, there are so many lectures on difficult questions. Okay, so now let's solve this question. Let's try to solve this question. This is a wedge. Okay, this is a wedge. This angle is theta. This angle is theta, and you know guys, here is a block. Here is a block, and this okay, and this block and this wedge moving this wedge moving with acceleration this wave moving with acceleration a. Okay, in horizontal, acceleration a in horizontal direction, horizontal direction, okay, horizontal direction. Okay, and in horizontal direction, this block is moving in horizontal direction with acceleration a. What you have to do? Okay, and there is, let me write this name a, and there is no relative motion, there is no relative motion between wedge and block A. Okay, you got this? This wedge is moving with an acceleration a in horizontal direction, and there is no relative motion between wedge and block A. Okay, find A. Find acceleration A if mass of block A is m kg. Okay, and this angle is theta. Okay guys. Okay, you know, if you had some common sense, some common mathematical sense, okay, so you know this, you had just realized, or just after reading the question, that this line is very important. No relative motion between the wedge and block. Okay, there is no relative motion between the wedge and block A. What it mean that if acceleration of wedge minus acceleration of let me write then some positive number. Acceleration of wedge minus acceleration of A should be equal to 0. Okay, because there is no relative motion. So acceleration of A minus acceleration of wedge minus acceleration of A block A should be equal to 0. And what is the acceleration of wedge? Acceleration of wedge is A in horizontal, so this is the acceleration of A, and this should be equal to 0. So what is the acceleration of A? Acceleration of A is in same direction. Okay, and this is the vector quantity, so let me write down in vector manner. Okay, so this is the very simple. Okay, it is very simple and anybody can calculate it if that guy has some common sense. Okay, so what it mean that you know this, what is the acceleration of A? What it mean that acceleration of A, so acceleration of A is in horizontal direction. Okay, what is the acceleration of A? Acceleration of A is A in horizontal direction. So it is very easy to calculate. Okay, it is very easy to calculate and realize. Okay guys, now we had find that this is the acceleration of A. This is the direction of acceleration. This is the direction of acceleration of A. Okay guys, so we had find then this is the direction of acceleration A. So this should be the my x-axis. This should be the, because if I take x-axis along this, then most of the time my question will be easy. Okay, so this should be the my x-axis. Okay, so there is a force mg, okay, which is just perpendicular to it, and again this is on wedge, so wedge will apply the normal reaction. It is very simple. Wedge will apply normal reaction. Okay, let me write down. Okay, wedge will apply a normal reaction. Who is applied normal reaction? Wedge on A. Wedge will apply a normal reaction on A, and this angle, again here is the important. What will be this angle? This angle will be 90 degree. Okay, because this is perpendicular. If I say normal reaction, then most of the time, okay, it is not always, most of the time the normal reaction is perpendicular to the surface. This is my surface and this is the perpendicular, so this angle will be 90 degree. Okay guys, okay, so wedge will apply a normal reaction on A. So this should be my normal reaction. Okay, this should be my normal reaction. Okay, so okay guys, this angle is theta. What should be this angle? This angle should be theta, because this is the horizontal. This angle, this is inclined with at angle theta with horizontal, and this is the horizontal, so this angle should be the theta, because these two are parallel. If this is theta and this total is 90 degree, this angle should be 90 minus theta. Okay, this angle should be 90 minus theta. So okay, if this is my x-axis, this horizontal is my x-axis, this is my y-axis, this angle is 90 minus theta, then this will be theta. Okay, these are the very simple calculation. Okay, you do not need to memorize all these things. So here this is the n, here this is the n, so this will be the n cos theta. Okay, this will be the n cos theta, and here there is a component, this will be n sin theta. All these things are very simple to calculate. This will be n sin theta. Okay, so what can I write? N cos theta is equal to mg, because there is no acceleration along vertical axis. Okay, So n cos theta should be mg, or n sin theta should be ma. Okay guys, so what, find the a. What is the question? Find a. Okay, if mass of block is m kg. Okay, find a. So let me write. What can I write? Tan theta is equal to a by g. It is very simple if you divide all this. Okay, so what is the a? G tan theta. G tan theta is equal to a. So guys, this is the very simple question, and it is the very simple question. And what is the importance of this question? You know, we had take this axis, a direction of acceleration as a principal axis. Okay, so what should be direction of acceleration? You should take that principal axis. Okay, so let me solve some another question, and all these questions are very simple. Okay. Okay, we are going to solve another questions, and in this question, this is a wedge, triangular wedge, and this is movable. Okay, movable. Okay, movable wedge. This wedge can move. Okay, and on this move wedge there is a mass, and this mass is m, and this mass is 2m. Okay guys, okay, this is wedge, this is block. Okay, here there is no friction. Here there is no friction. There is no friction. Okay, so there is no friction. Okay, and what you have to find acceleration of A. Find acceleration of wedge. Find acceleration of wedge. And second thing is find acceleration of block acceleration. Okay, find acceleration of block and find acceleration of wedge. We have to find these two acceleration. Okay guys, you know, this it looks very simple. But it is slightly complicated, and you know, you find there are so many methods to solve this question, and we are not going to see different type of method. What I am just going to give you some ideas how to solve this question. Okay, and people will tell you to solve it by pseudo force, by this force, by that force, by, okay, there are so many methods to solve this question. And okay, but I do not believe to at this stage you are able to, it is good thing to bombard you with all type of method. Okay, so right now we are going to solve this question. By our simple method. Okay, by whatever we had learned. Okay guys, so what is the first thing? You know, the first thing is we have to realize what should be the direction of acceleration. Since this wedge is moved, you know, but one thing I am sure, that it is not flying in air. This wedge is not flying in air. Okay, this wedge is not just started flying in air, just moving upward. Okay, it is not possible, it is not doing that. What this wedge can do is, this wedge can move only in this direction. Only in this direction. Okay, or that direction, only in this direction or that direction, along the horizontal. Okay, along this ground, along the horizontal, it is not going to fly. So one thing is sure. Okay, so let me write down, let me draw the free body diagram for this wedge and write down the equations. Okay, let me draw the free body diagram for this. Okay, for wedge, let me draw the free body diagram for wedge. And I had no, okay, let me draw the free body diagram. This angle is theta, and here there is a normal reaction, here there is normal reaction. Okay, here there is a normal reaction, and here there is a normal reaction, and okay, and let this normal reaction, and this is on ground. Here this is the 2 mg, which is 2 m is the mass, 2 mg, and here this is the normal reaction by ground. Let me write it. And okay, and okay, since this block, and if you look very carefully, okay, so here is one important thing is that what is the direction of motion? What is this horizontal? The direction of motion is along the horizontal. So we should take horizontal line as a principal axis. Okay, as my principal axis, we should take horizontal line as my principal axis. This is my horizontal line. Okay, it is very simple. We should take a horizontal line as my principal axis. Okay, so if this angle is theta, this angle will be theta. It is very simple. And then this angle will be 90 minus theta, 90. So this angle will be again 90 minus theta. Okay, it is very simple to calculate. And this is the n. So what is the component along this? N sine theta, and sine theta, because cos 90 minus theta is equal to sine theta. So what should I write? What should I write? N sine theta, and sine theta is equal to, let's suppose acceleration of this block is, this wedge is A. Let's suppose acceleration of this wedge is A. Okay, so n sin theta is equal to 2ma. Okay, it is very simple to calculate. Okay, so we should just forget about this right now. Okay, we will use it whenever it's required. Okay, now guys, now I am just going to solve this. Okay, so one thing we should do it. I should analyze the what is the direction, what is the direction sense of motion, how this wedge, how this block M will move, how this wedge will move. Okay, what I'm going to do, I am going to analyze how this wedge will move. Okay, so let me draw. This is the important, the first step of solving Newton's law is to find sense of motion, how motion is taking place, what is the relation between different connected bodies. Okay, what is the relation between different connected bodies along what is the relation between different connected bodies. Okay, then we are able to find. Okay, so let us analyze. Okay, this is the dotted line, and this particle is on, and this is a wedge. On wedge there is a particle. Okay guys, okay, guys, this particle cannot move in air. This particle cannot move, is not living. This particle is not living. This particle is not living this wedge. Okay, this particle is not living this wedge. This particle is not living this wedge. Okay, this particle is not living this wedge. This means that you get, what I get, what I'm trying. So this block is not living this wedge. Okay, this means what it means that and this wedge is moving. This wedge is moving, and this wedge is moving in this direction. This wedge is moving in this direction. Okay, let me suppose this wedge has moved by amount x. This wedge has moved by amount x. So this will be the x. This will be the x. So what is the, and now this block is not moving. This block is not moving. This block is not living this wedge. What it means that if this has moved x, then then the component, then and this is y. Okay, this is y and this is y. Okay, what it means that the component of x should be y. The component of x along this axis should be y. Okay, it is why it is so. Why it is so. Think. I am not going to think about it. Okay, if I explain, a huge mess will created. Why it is so. Think about it. Okay, think about relative motion. What is the hint? What is the hint? Think about relative motion. Think about relative motion. Okay, this is the hint. And from me, I don't think there is any further explanation will require. Okay, why it is. Think about a hint. What is the hint for it? Think about relative motion. Okay, think about relative motion. So you had to think. It may take 3 day, 4 day, 5 day. It is okay. Okay, but you should think about it. Why? Why if it is not leaving the surface, then component of x cos theta should be equal to y. Okay, guys, so what can I write? So cos theta, this should be equal to okay, this is the very simple to realize when you had done kinematics classes. Okay, this is the very simple to realize. So what can I write? What is a dx d2x dt2? This is the acceleration of prism, which is a, so a. Okay, this is not cos theta, this is sin theta, because this angle is theta, this will be 90 minus theta, this will be sin theta. Okay, sin theta. Okay, this will be sin theta. Okay guys, so sin theta is equal to d to t upon dy2 by dt. So a sin theta is equal to d to this is, which is acceleration of block along y. Okay, a1, acceleration of block along y. Okay guys, so it is very simple to calculate and you should do it by yourself. Then you will find that it is very easy. It is very easy to do it. Okay, it is very easy to do it. Okay guys, so let me, okay, now okay, guys, this block can move along this, okay, along this without any restriction. This block can move along this without any acceleration. Okay, so this block has this block can move along this. Block can move along this, okay, along this inclined, okay, check the spelling, inclined surfaces. Okay, this block can move along this inclined surface. It is very easily move. Okay, it can move along this inclined surface. Okay, so if I say acceleration of block, is acceleration of block is, there's two acceleration of block. One is, if this is the inclined plane, this is the angle theta, then there is two acceleration of block. One is along this, one is along this. We have to calculate. Let me suppose this is the A1, and second is A1 cos theta. Okay, A1 A sin theta. Second is A sin theta. And how we find? By geometry. How we find by geometry. Okay, in some real time I calculate how, explain how it had come. Okay, we think about relative motion and how we find by geometry. Okay guys, okay, listen, in my when I giving some basic question, basic lecture, so I am explaining you to find relation between like this. If this block is connected, so what should be the acceleration of this block. Okay, I had taken this A1, A2, A3, then try to find out what is the relation between them. Okay, here we are doing the same thing. This is my A, this is my B, and this is my block A, this is my block B, and I had tried to find out what should be a relation between acceleration of block A and block B. Listen, the relation is, if this block is moving in with acceleration A along this horizontal line, then what should be the acceleration of this along vertical line? Along vertical line should be A sin theta, or any acceleration can be along A1. Okay, any acceleration can be along A1. Okay, so here he whatever he do here is same as here. It is not new. Okay, it is not new. So okay, I have find what is the along this A sin theta. Okay, here is A1. Okay, now we should draw the free body diagram. We had analyzed the direction of acceleration, etc. Now we should draw the free body diagram. Okay guys, there is two sense of acceleration. So I should take this as my principal axis, and another is along perpendicular to this. Okay, so it will automatically become my y axis. So let me solve this. So let me draw the free body diagram. Okay, here this angle is theta, then this angle will be 90 minus theta, this angle will be theta. Here mg, so this component will be mg cos theta, mg sin theta. Okay, mg cos theta, and along this there is a component called mg sin theta, and again here there in this direction there is a normal direction. Who has applied this normal direction? Wedge. Who has applied this normal direction? Wedge. How I know it? My Newton third law. Okay, so since this is my direction of acceleration along y axis, so I should take mg cos theta as a positive. So mg cos theta minus n is equal to ma sin theta, and again mg sin theta is equal to ma1, because there is acceleration along this is y. So I had balanced the force along fy. I have balanced the force along y axis, and this is the balance of the force along x axis. Okay, so what is the a1? What is g sin theta is equal to a1. Okay, and again now we have to find this. Okay guys, so we had mg cos theta minus n is equal to ma sin theta, and if you look this, what is it? N sin theta is equal to 2ma. Okay, it is given that n sin theta is equal to 2ma. If you solve it very carefully, what you get? Mg cos theta sin theta. What you get? Mg cos theta sin theta divided by 2m plus m sin square theta is equal to a. If you look at very carefully, it becomes g sin theta cos theta divided by 2 plus sine square theta divided by 2 plus sine square theta. So it is very simple to calculate. It is very simple to calculate.
Hey buddy, hope you understand whatever I am explaining to you. So work hard and enjoy the life. If you want to see me tomorrow, then subscribe my channel, because viewers like you support and motivate us to make videos. Please share this by clicking on the share button on Facebook, Twitter, Instagram, and other social networking sites, so that anyone get benefit and spread about it among your friends. My dear students, an important message for all of you. We are trying to take an online exam, which will be totally free for trial period, means till July 2017. If you are interested in it, then you can register by sending an email or a message on WhatsApp. My WhatsApp number is 700-771-9110, or by giving this call on 7755896-205. We will give more detail about it in our forthcoming videos. Thank you so much.